So in the last video, we started with the chapter Combustion and Flame of Class 8. So in the part 1 of this video, we firstly saw what is combustion. So combustion is when, when a substance presence of air. That process is known as combustion. Now next, fuel. So any substance combustion is known as the fuel. Then we learned something about the ignition temperature. So ignition temperature, it is the lowest temperature at which a substance ignition temperature. Further, we learn about inflammable substances. Now, inflammable substances are the ones whose ignition temperature is their ignition temperature is very low and they can easily catch fire. So these are inflammable substances. Now, then we learn about the essential requirements for producing fire. So in that first we had the fuel, then we had air, and last we had heat. Lastly, we learned about the types of combustion. So first we had rapid combustion, we had spontaneous combustion, and we had explosions. This we learned in the part 1 of this chapter. Now today we'll learn about flame, then the structure of flame, then further and fuel efficiency. Now when we talk about flame, what do we understand by the term flame? So observe an LPG flame. Can you tell the color of the flame? What is the color of a candle flame? So now all of us have seen a flame, that is a candle flame. We have seen that the outer region is like slightly orange. Then we have the yellow region and then a even lighter yellow region. And on the outermost part, we sometimes see a blue region. So now recall your experience of burning a magnesium ribbon in class 7. If you do not have experience of burning the remaining items in table 4.2, you can do that now. So when we burned magnesium, we saw that there was a bright light or a very bright flame or a very a very bright spark kind of thing that was created. So now see here they have shown we have a LPG gas flame and this is the candle flame. So we can see the difference here that the LPG gas flame is very much blue in color, whereas this one is more on the warmer side, that is like it has yellow and orange. Now, structure of a flame. So here there's a activity. Light a candle, hold a 4.5 centimeter long thin glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube Do you see a flame caught at the end of this glass tube after a while? If so, what is that produced a flame? Notice that the wax near the heated wicks melts quickly. So now what they are saying is that what they have done here, they have taken a lighted candle here and they have placed a glass tube over here, and at one end they have lighted a matchstick. So now what is happening here is that we can see a flame being lit at the other end of the glass tube. So now why is this happening? So the substance which vaporizes during burning gives flame. So now what is happening here is there is the process of vaporization. There is vapors that are released here. Okay, so the substance which vaporizes during burning gives out a flame. So due to the vaporization of this candle, there is the flame that we can see. Now, for example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Charcoal, on the other hand, does not vaporize, so does not produce a flame. So when we notice, there's a difference when you burn charcoal and when you burn a candle. So when you burn charcoal, you won't see any flame, but you can see the substance being heated. Like you can see the redness in the substance, which indicates that it is hot and it is burning. Whereas in the flame, we can see clearly the flame image that is produced. Now this is because here the candle is getting vaporized and therefore there is production of this flame. Whereas in charcoal, there is no such vaporization occurring. Therefore, there is no flame that we see. So now, when a candle flame is steady, introduce a clean glass plate slide into the luminous zone of the flame. Hold it there with a pair of tongs for about 10 seconds. Then remove it. What do you observe? So now what they are saying is just take a plain glass plate or a glass slide and place it above the candle. So basically what we'll see is like a dark patch like kind of thing in a circular form that will be produced over there. Now what is that dark patch? So a circular blackish ring is formed on the glass plate slide. It indicates the deposition of unburned carbon particles present in the luminous zone of the flame. So here they are saying that blackish kind of thing that is formed on that glass slide is due to the deposition of unburned carbon particle present in the luminous zone of the flame. Okay, so then hold a thin long copper wire just inside the non-luminous zone of the flame for about 30 seconds. So now when you hold a thin long copper wire right in the center, okay, non-luminous zone is the right in the center, or sorry, right outside. Non-luminous zone is the outer sides. Only for 30 seconds. What you'll notice is that copper wire which was there, it will be turning red. Okay, it gets red hot. This indicates that the non-luminous zone of the flame has a higher temperature. In fact, this part of the flame is the hottest part. So now what has happened here is that the luminous zone. So the luminous zone is this region over here, this inner part over here. So when we took the glass slide and we placed it over there, we suppressed the flame over there. So therefore our slide was somewhere over here. So it was in this part of the flame. So therefore there was that blackish ring that formed, which indicated deposition of the unburned carbon particles. Okay, now further when we take a copper wire and place it at the outer end, that is the non-luminous zone, we saw that, and that too we placed it only for 30 seconds, that are very few seconds. So that is when we saw that the copper wire turned red hot. So that indicated that the non-luminous zone is the hottest part of any flame. So now let's look at this diagram over here. So this part which is there, okay, so this part now which is there over here, this part, that is the non-luminous part, whereas this outer region which is there is the luminous part. Okay, so now this outer part, that is the outer zone of complete combustion, I told you also in the beginning that on the outside we can see a slightly blue kind of flame color, that is the hottest part of the flame. Then we come to the moderately hot part, that is the luminous zone where we placed our glass slide. So that is the moderately hot zone and it is known as the middle zone of a partial combustion. So there only partial combustion happens and it is yellow in color. And the least hot is the this last part, that is right near the wick, that is the innermost zone of unburnt wax vapors, that is black. Okay, and this part is known as the dark zone. So we have three parts. We have the luminous zone, that is this inside part, the middle moderately hot part, non-luminous zone, that is this outer zone, that is the hottest part, and this part near the wick, that is known as the dark zone. Now, goldsmiths blow the outermost zone of a flame with a metallic blow-pipe for melting gold and silver. Do they use the outermost zone? Why do they use the outermost zone of the flame? So, this is why. Now, when we talk about gold and silver, their melting points are very high. So, that is the reason that they are saying that the goldsmith blows in this outer non-luminous part, because here the temperature is very high as compared to the inner part. Now, what is a fuel? So, in the beginning, we spoke about fuel and we said that any substance that undergoes combustion is known as the fuel, or it is known to be combustible. Now, recall that the sources of heat energy are domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called as fuels. So now, here they have named some domestic and industrial purpose fuels. That is, mainly we have wood, charcoal, petrol, and kerosene. This we use in our day-to-day life also. These substances are called as fuel. Now, a good fuel is the one which is readily available, it is cheap, it burns easily in air at a moderate rate. Now they are telling what are the characteristics of a good fuel. First is that it should be readily available. Second is it should be cheap. And third is it burns easily in air at a moderate rate. Then it produces a large amount of heat. It does not leave behind any undesirable substances. So a good fuel is the one which is firstly readily available. Secondly, it is cheap. Thirdly, it should produce a large amount of heat. Fourth, that it should burn with a moderate rate. And fifth is that it should not leave any undesirable substances behind. There is probably no fuel that could be considered as an ideal fuel. We should look for a fuel which fulfills most of the requirements for a particular use. Now, these are all the properties of an ideal fuel, but these you won't find in all the fuels. You won't find it in all the fuels. So, we have to see based on the type of particle or substance we are burning, what are the characteristics we need. So in that case only we can term it as a good fuel. An ideal fuel is not possible to be found. Now, fuel efficiency. Suppose you are asked to boil a given quantity of water using cow dung, coal and LPG as fuel. Which fuel would you prefer? Give your reason. So obviously now if you are told to boil water on waste using cow dung, coal or LPG, obviously we'll use LPG because that is faster and also the heat that is produced over there is in larger quantity. Or you can say you can adjust the heat that you supply. So do these three fuels produce the same amount of heat? No. The amount of heat energy produced on complete combustion of 1 kg of fuel is called its calorific value. So now calorific value is the amount how much of heat is produced when 1 kg of any fuel is burnt. That is known as the calorific value. So calorific value tells us the amount of energy produced. So the calorific value of a fuel is expressed in a unit called kilojoule per energy. Kilojoule, why? Because we are basically measuring the energy level here. So see here now. Firstly, we have cow dung cake that has a calorific value of 6,000 to 8,000. Okay, then we have wood. Coal has 25 to 33,000. So here on burning 1 kg of these, there's a lot of energy that is being produced. So out of all of these, cow dung produces the least energy on burning 1 kg of this cow dung. Then now see we have LPG here. So LPG produces 55,000. So that is almost the highest one in case like if we use LPG, CNG, methane, or if we use coal and cow dung, LPG produce the highest one. And lastly, the most highest one is the hydrogen that produces around 1,50,000 has a 1,50,000 calorific value of calorific value. Now, burning of fuel leads to harmful products. Now, what happens when we burn these different types of fuels? Now, they are having advantages, but they are also having disadvantages. Now, let's see what are those disadvantages. The increasing fuel consumption has harmful effects on the environment. Now, carbon fuels like wood, coal, petroleum release unburnt carbon particles. These fine particles are dangerous pollutants causing respiratory disease such as asthma. So now when they are saying when we burn carbon based material, that is wood, then coal, petroleum, these produce very tiny particles which are very harmful for our respiratory system. This particles when we inhale, they pass through our respiratory system and can cause us respiratory problems like asthma. Next, we have incomplete combustion of these fuels give carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill persons sleeping in that room. So now what happens is that incomplete combustion is there is a less presence of oxygen in the surrounding. So now what they are saying, say now we are burning that same, okay, we are burning say coal, we are burning and we are burning it in a closed room, and in one place we are burning it in an open area. So what happens in the open area is that carbon monoxide that is formed, it combines with the air that is already present in the surrounding. So therefore it goes out as carbon dioxide. But when you are restricting the amount of air in a closed room, so when you are trying to burn coal in a closed room, what will happen is that whatever air is there will get consumed. Okay, some amount of CO2 will be produced, but then after some time that carbon monoxide will remain as carbon monoxide because there is no more air supplied to provide oxygen. So in that case, carbon monoxide remains as carbon monoxide, and carbon monoxide is a very poisonous gas. It is dangerous to inhale this gas. It can even kill a person. Now next is carbon dioxide in the environment. Increased concentration of carbon dioxide in air is believed to cause global warming. Now, when you produce or when you burn a lot of fuels, it will eventually increase carbon dioxide levels in the environment, and this carbon dioxide levels, they increase the global warming. Now what is global warming? So global warming is the rise in temperature of the atmosphere of the earth. Okay, so here what happens is further when the temperature rises, what will happen? The glaciers will start melting. That will result in flooding in the coastal areas, or the sea level will eventually rise. Then that will also sometimes that level will rise so much that it can submerge any low-lying coastal areas that are present. Next, Burning of coal and diesels releases sulfur dioxide gas. It is extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rainwater and they form acids. Such rain is called as acid rain. It is very harmful for crops, for crops, buildings and soil. So now what they are saying here is that when we burn coal and diesel, they release sulfur dioxide gas. Okay. Now that is very, firstly it is very corrosive gas, and secondly it is very suffocating. It can suffocate you to death. Now in that case, moreover, petrol engines give off gaseous oxides of nitrogen. So vehicles that run or automobiles that run on petrol, their engines give off nitrogen oxide, that is nitrous oxide, which is also very dangerous. Now when these oxides of sulfur and this nitrogen, they dissolve in rain, they produce something called as acid rain. So in that case, these acid rains are very dangerous because they have a mixture of two very dangerous gases. One is the sulfur dioxide gas and the second is the nitrous oxide gas. So when these two combine with the rain, they produce acid rain, and that is very harmful for crops, buildings and soils. The use of diesels and petrols as fuels in automobiles is being replaced by CNG, because CNG produces the harmful products in very small amounts. CNG is a cleaner fuel. So now, because of these reasons, because these diesel and petrol based fuels are producing carbon dioxide, they are producing nitrous oxide, sulfur dioxide, these kind of gases. Now the shift is happening from petrol, diesel to CNG. CNG is compressed natural gas. Now this compressed natural gas, it produces very less amount of these harmful products, and therefore it is known as a cleaner fuel. So in this chapter, we learned the substances which burn in air are called combustible. Oxygen is essential for combustion. During the process of combustion, heat and light are given out. Ignition temperature, it is the lowest temperature at which a combustible substance catches fire. Inflammable substances have very low ignition temperature. Then fire can be controlled by removing one or more requirements essential for producing fire. That is, you remove the fuel, or you remove the air supply, or you remove the heat that is being produced. Then water is commonly used to control fires, but water cannot be used to control fires involving electrical equipments or oils. In that case, it will make the situation even worse. There are various types of combustion such as rapid combustion, spontaneous combustion and explosion. There are three different zones of a flame. That is the dark zone, that is the zone near the wick of a candle. Luminous zone, that is the middle part, and the non-luminous zone, that is the most hottest part, that is the outermost zone. An ideal fuel is, beside it is cheap, it is readily available, readily combustible, and it is easy to transport. Also, it needs to have a high calorific value. It does not produce gases or residue that pollutes the environment. Fuels differ in their efficiency and cost. Fuel efficiency is expressed in terms of its calorific value, which is expressed in the units of kilojoules per kg. Why kilojoules per kg? Because it is the amount of energy that we are measuring. Unburned carbon particles in air are dangerous pollutants causing respiratory problems. Incomplete combustion of a fuel gives poisonous carbon monoxide gas. Increased percentage of carbon dioxide in air has been linked to global warming. Oxides of sulfur and nitrogen produced by the burning of coal, diesel and petrol causes acid rain, which is harmful for crops, buildings and soil. So this is what we have learned in this chapter. So thank you so much for watching today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.